Welcome to Earth Science, everybody. Good morning. It's time for the new unit, which is called Air is Stuff. We're going to just look at the idea that air actually is something, which sometimes you take for granted. Sometimes I think it's pretty obvious. Like if you went outside last night and it was gusting like 40, you would have noticed that air actually is something as it blew in your face. But other times it's just like, it's clear. You don't necessarily see it. You can travel through it. You can throw something through it, right? Like what do we see to show us that there is actually something there? And I've got some cool classroom experiments that we can't do this year from home. But we can still try to demonstrate that point through the work that we usually do. So, more graphing. Here we go. You're going to take a look at the layers of the atmosphere as you work your way from the surface up. Now, it's valuable to think of the atmosphere in terms of living at the bottom of an ocean. Like if you're a lobster, picture a lobster that's scampering around on the bottom of the ocean, right? It's on what it considers the ground, and it's got stuff around it, the ocean, water, right? It's kind of the same thing up here, only the medium's a lot thinner. Air is a lot thinner than water, less dense, it's easier to move through. But the mechanics of it, fluid dynamics, a lot of that is actually the same. So we live at the bottom of this thick ocean of air, and that's what we're going to look at today by checking out the 4 layers. Now, there's been some brief allusions to this reference table in some of the earlier labs you did, so some of this might seem a tiny bit familiar, but today's the day where we get a little bit more involved. I would like you to do all of these steps and check them off as you go. Now, I've been around long enough to know that when I say step 1 is to read the writing, that people in 8th and 9th and 10th grade tend to not do that. So you can skip that for now, but you're going to have to come back when we do another thing. So I'm guessing if you do this the way that most other people have done this through the years, that you're going to start on step 2, which is graphing the points from the temperature table onto the atmosphere graph. All right, labeling them. You're not going to use a ruler. You just draw a line. And then you can do some drawings, which, I know is difficult. I'm terrible at drawing with a regular pen and pencil, let alone this Cami stuff. But I'll show you. Don't panic. It's going to be easy. So here's all the data you're going to graph. It's basically one long data table. Like it goes 0, 5, blah, 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 up to 48, and then picks right up here at 52. So it's not 2 separate sets of data. It's going to be one line. And it is what happens to temperature as you go up in altitude. Now, this is going to be where the different layers start to show themselves up. You live, and in fact, you've most likely spent your whole entire life in the bottom layer, the troposphere. So when we talk about weather and all of that, this is really what we're talking about. Yes, there's other layers and stuff happens up there, but we really focus on the troposphere. In fact, I should say troposphere every time I say atmosphere when we're doing weather. You tend not to, because atmosphere just comes tumbling out your mouth, but really that is the talking of the troposphere. Excuse me. So what happens as you go up in altitude in the troposphere? Well, we're going to find out. Or picture a very tall mountain. What's up there at the top? You'll find out. Yes, later you're going to have to come back and draw these things. Now, look at, I can't even write draw, let alone actually draw. So my expectations for what these drawings are going to look like, this is not art class. You're not going to be judged by that. An airplane. How is that? Of course, it's going to go in the diagram down below, but that's what I'm saying. That's pretty good. I'll take it. A mountain, just draw a triangle. Ozone, just draw O3. The trick is that you're going to have to say, where are these things later on once you've plotted the graph? And the only way to know where they are is if you actually come up here and do the reading. Then some questions and all of that. So if you're like most people, you're going to start off with graphing. This has always been a little bit funny, this lab. I should just redo it, but the number is for that line right there. So -10 is for that line right there. So if you look at your data, I don't know how you guys like to do this. If you like to use a separate screen, or you can split your screen and do 2 tabs. I got mine over here. So at 0 kilometers up, it's 15 degrees. I'm going to do the first whole bunch of points for you, so that if you watch this with the video, you can just kind of fight along with us. So at 0 kilometers up, it's 15 degrees. I'm saying that's right about there. I might even like bigger dots for this. Yeah. At 5 kilometers up, it's negative 18. So if that's negative 10, that's negative 20. We're about halfway between and 5 kilometers up. Right there. I like it. At 10 kilometers up, we're at negative 49. Pretty much negative 50, right? Boom. Right there. There we go. At 12 kilometers up, one funny thing in this lab too is that the data isn't set up to be like the data points aren't linear. It's fine. It's as you go up. They send these big weather balloons up that can pick up this as they go up. So at 12, it's negative 56. A tiny bit colder. I don't know. What do you think about there? At 20, it's also negative 56. So this is usually where people are going to say, if we were in class, Mr. F, I think I'm doing this wrong. But you're not. You're doing fine. At 25, it's negative 51. So 25, negative 51. At 30, it's negative 46. All right, so there's the first chunk of points. I'll do one more. At 35, it's negative 37. Okay, so this is how we've figured out that there's different layers of the atmosphere or different things going on, is that we've watched what happens to temperature as you go up. As you go up through the troposphere, it gets colder, 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 colder. Again, think of tall mountains, a snow-packed mountain, ice-capped mountain. It's cold up there. It's cold as you go up in the troposphere. But you get to this line right here, and then it starts to warm up. So the next layer up, the stratosphere, it actually gets warmer as you go up through the atmosphere. And you're going to have to figure out why that is. Not really figure out, you're going to have to read and just tell me why that is. It does want us to draw lines. You have to do, I've never really used the line tool here. Let's see how it works. You're going to have to do a line in between the layers. And how do you know where the layers end? Well, this is the definition of it. It's where the temperature shifts. So you're going to see that this goes up. It goes as you go up in the atmosphere, it decreases, it gets colder. Then you get into the stratosphere and it starts getting warmer, 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 warmer. And then as you guys plot the rest of your data off that data table, you're going to see that it switches again and then starts to get colder. And then it switches again and starts to get warmer. So every place where it switches like that, you're going to have to be clever enough to find that. We're going to draw a line. If you can figure out how to use the line tool, you could just do it freehand with the regular pen as well, but maybe not make it quite as thick. It'd be cool if you could move this too. I wouldn't mind if this were a teeny touch taller. Anyway, play with it, see if you can get it. It's all right there. I'm not going to complain at the end of the day. And then you're also going to label all these layers and all of this. So this is the troposphere. Oh, let's use the right keyboard. I don't know what I did to that. It's also going to tell you to label the things called the pauses. The pauses are the ends of the layers as you go up through the atmosphere. They're not super hard to name. This is called the tropo pause. Didn't have my coffee yet. And the internet doesn't like how that's spelled, but tough. It's correct. So troposphere ends with the tropopause. This will be the, I don't want to do this whole thing for you, but this can be a little confusing if you're just jumping in on your own. So stratosphere. And then you'll label all those until, again, the temperature switches again and starts getting colder again as you go up. You'll draw that line there, and that'll be the stratopause. And then what's the name of the next layer? What's the name of the last layer? And the pauses that go with those. All right. Hopefully that treats you all right. Now, the drawings. It'll be like, okay, I have to draw these 8 things somewhere on that diagram once it's entirely complete. But I'll do the first one for you to help you out. Again, I've already told you this. Everything you do, everywhere you've been, is all in the troposphere. Some very high planes can get into the stratosphere. but you've really spent most, if not all, of your life there. So what you got to do is look through here and say, blah, 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 and try to find where all those things are. Like mountains. So there it says it right there. All mountains, even Mount Everest, are all exist inside the troposphere. So now you know, okay, Mr. F's asking me to draw a mountain. That writing said that it is in the troposphere. So all I got to do is come down here and draw a mountain. Draw a happy little mountain. Channel your Bob Ross. Don't get angsty, angry, frustrated at the cami. What do you think? Quite a mountain. I like it. Mount Everest should be 8.8, but that could just be any mountain. Doesn't matter. So yeah, what do you think? That should do it. Then you're going to, once you do all of those things, you got a couple of questions here. Maybe I'll look at posting a couple other little like mini questions just to get you using the reference table. Also, a link to the reference table. If I had to guess, I'm thinking this is around page 14 of the reference table, but I'll make sure to write that on the other thing. Any of these too tough? What divides the atmosphere into 4 layers? It's really just what happens to temperature, that it gets colder and warmer. Now, yes, it's because there's different gases and some different things going on, but I don't know. That's maybe a slightly fuzzy question. Just steal that answer. What happens to temperature? Does it increase or decrease? Well, in the troposphere, as you're going up, it decreases. Tell me what happens to the others. Approximate height of the tropopause, stratopause, mesopause. You'll just read it right off of the lines that you made, wherever you made them. I made mine right about 15 for the tropopause. So hopefully those aren't too bad. And I think that just about does it for this little, this says lab. This isn't really a lab. This is just a worksheet I've used for years. All right. Hope that goes well. Check the survival guide for anything else that I'm going to throw on you at the last minute here. Keep it up, folks. Welcome to a new unit. Hopefully we'll see you soon.